All right, this is a walkthrough of the final study guide of the year for IM1. Let's get into it. Number 1, determine whether the situations are linear or exponential. Remember that if a situation is describing a linear function, that means you're adding or subtracting each time. It's growing at a constant rate, it has a slope. If it's exponential, then it's not growing at a constant rate, it's growing faster and faster or shrinking faster and faster. And it would the graph would be curved. You'd end up multiplying. Another way to think of it is, well, I'll use this as an example. Scenario 1 says that our annual insurance policy costs $1,000 a year, and each year it increases by 80. That means you're adding $80 to the policy to the cost of the policy each year. So next year it would be $1,080, and the next year it would be $1,160. It's going to form an arithmetic sequence where you're adding from term to term, and that means it's a linear function. In contrast, scenario 2, we start with a car that's worth $30,500 and it depreciates in value. It reduces its value by 35% each year. That means that it starts out with 100% of its value and we're subtracting 35%. I wrote it out as a decimal, but this is that decay factor. So our decay factor would actually be 0.65, and we could multiply 30,500 by 0.65 to find out how much the car is worth the next year. And whatever that number is, we could multiply it by 0.65 again to see how much the car would be worth the following year. And that would not be linear. We're multiplying instead of adding each time. So it would form a geometric sequence, which means it's an exponential function. So the answer is B. Similarly, for number 2, one scenario is increasing by 10%. When we're talking about increasing or decreasing by a percentage, we're multiplying by like 1.1. That's 100% plus 10% more. Or in the last one, 100% minus that percent. Either way, it would form a geometric sequence or an exponential function. In scenario 2 for number 2, it's reducing by a flat amount. We're subtracting $110 each year. That would be linear because it forms an arithmetic sequence. So our answer would be D. Number 3, which graph shows a triangle reflected over the x-axis? Well, that would be D. Here's the x-axis, and this triangle is reflected over to form this triangle. Number 4, we're looking for a graph that shows line segment AB, that's the figure, and its image. So it can't be C, it can't be D. We had one like this on the chapters 8 and 9 test. It's A because line segment AB is graphed correctly. It can't be B because this should be AB, but it's marked as A prime, B prime. And it's confusing the pre-image with the image. Number 5, we're rotating 90 degrees clockwise. Notice how BC, it turns that way 90 degrees. That's what we want. You can draw points from B to the center of rotation to B prime. It makes a 90-degree angle. You could do that with A. You could do that with C. 90-degree angle. You could even do it with D. Same thing for number 6, except it says counterclockwise. So we're rotating the other way. And that would rotate BC to B prime, C prime over here. 90-degree counterclockwise rotation. Number 7, which pair of triangles is congruent by angle, side, angle? It's D. We have angle, side, angle, angle, side, angle. It can't be A because even though this triangle matches up with, it describes an angle, the included side, and an angle, the second triangle does not. This is angle, angle, side. Number 8, we need to remember the reflexive property here. But as long as we do that, we can immediately conclude that triangle ABD is congruent to triangle CBD. And that's because we know this angle, and this side. My question for you is this side the connecting side? Is it the side between the two angles? No, it's not. That would be this side here. So it can't be angle, side, angle. It's angle, angle, side. Number 9, we know that these two angles are congruent. We know that these two angles are congruent. So which additional statement would not allow us to prove that these two triangles are congruent? It would be B, because then we'd have angle, 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 and that does not prove triangle congruence. All of the other choices, if you drew it out, like for example, choice A here, if I knew that BC was congruent to EF, I would have angle, angle, side, and that does prove congruence. So the answer is B. Number 10, we know vertical angles are congruent. So we end up with one pair of congruent sides, one pair of congruent angles, and a second pair of congruent angles, which means I can use angle, angle, side because I have two angles in one side. I can't use side, angle, side though. I would need a second pair of congruent sides to use side, angle, side. Number 11, we're filling in the blanks to this two-column proof here. I color-coded it for you. So this given information is in blue and in green, there and there. And then the red part is just saying that vertical angles are congruent, so that's marked in the picture as well. And then line 3 says that the two triangles themselves are congruent. Triangle PRQ is congruent to triangle SRT. And that's because of these three statements above: angle, side, angle, angle, side, angle. So the reason for statement 3 is angle, side, angle. Now that we've shown that the triangles themselves are congruent, we know that corresponding parts of congruent triangles are congruent. So PR is the corresponding part in the first triangle to SR in the second triangle. So these two must be congruent because corresponding parts of congruent triangles are congruent. Number 12, it's asking you to select the increasing intervals on this graph. So choice A is from when x is 2 to when x is 3. So I'm looking for the point on the graph with an x-coordinate of 2, that's right here, and the point on the graph with an x-coordinate of 3, that's right here. And I'm interested in all the x values between those 2 points. That's this interval here. It is going up from left to right, so we circle A. We can do the same thing for B and find an increasing interval from 4 to 5, so that one's also an answer. But from -1 to 0, that's from here to here on the graph, it's going down from left to right, so we don't circle C. The answers are A and B. 13 is asking for the increasing intervals as well. Notice that A, from -3 to -2, that's an increasing interval. From left to right, it's going up. B is not increasing, it's decreasing, going down from left to right. C is tricky. Don't be fooled. It has a part of that interval that's increasing, but part of it is also decreasing. So this is not counted as an increasing interval. In order to be increasing, it has to be increasing for the entire interval, and it's not in that red interval. So don't circle C. It's just A. Number 14, you are given an input, 9. And you need to evaluate the function. So h of 9 means plug in 9 for t. 50 minus 9 over 3. Well, order of operations says we divide first, and we'll get 3 there. 50 minus 3 is 47. Do the same thing for 15. Plug in 60 in for r, and you should get 58 as the output. Okay, so the only thing you have to do is the blue part. I got some extra practice here for you if you want. It's asking what is f of -8? So in other words, what's the output when x is, or what's the y-coordinate when x is -8? Well, the first thing we need to do is find the point on this graph with an x-coordinate of -8, and that would be this blue dot right here, because that's when x is -8. The y-coordinate would be 9, so that's our output. Try a couple more. You don't have to do these, but if I asked you for f of 2, well, where's the point on the graph with the x-coordinate of 2? That's this green point here, and the y-coordinate of that point is -5.5. It's right in between -5 and -6. So that's why we have negative 5.5 there. F of 9, well, the red dot here is the point on the graph with an x-coordinate of 9, and its y-coordinate is 5. So f of 9 equals 5. The next problem is going to be a little bit more difficult than this, but it's the same idea. Now we have two graphs, and we are asked to find 4 times f of negative 2 minus 2 times g of 4. So let's find out what is f of negative 2. Make sure you're looking at function f and not function g. So what's the point on the function f with an x-coordinate of negative 2? Well, that would be this blue point right here. And f of negative 2 is the y-coordinate of this blue point. It's 4. So I replace f of negative 2 with 4. I don't write x anymore. I don't write f anymore. It's just 4. I do the same thing for g of 4. So the point on function g with an x-coordinate of 4 is right here, and the y-coordinate of that point is 5. So g of 4, I can substitute 5 for g of 4. After that, I just need to remember my order of operations. I definitely multiply before I subtract, right? So 4 times 4 is 16, 2 times 5 is 10, and 16 minus 10 is 6. Number 18, what is the input value for which the output of this function g is equal to 64? Well, that just means set g equal to 64. Negative 9x plus 1 is the function g, equals 64. I can subtract 1 from both sides and get negative 9x equals 63. So negative 9 times what number is 63? It's 7, or negative 7 rather. Number 19, what's the input value for which the output of this function is negative 7? That means the y-coordinate is negative 7. So where's the point on this graph that has a y-coordinate of negative 7? Well, this dotted blue line is the equation y equals negative 7. There's only one point on the black line that has a y-coordinate of negative 7. It's right here, and the input, the x value of that point, is negative 4. Number 20, consider the function f whose graph is shown below. What's the domain and what's the range? Remember, the domain is all the x values of the graph. So if you were to ask me, well, what's the y-coordinate of the graph when x is negative 8? I can't tell you. The function's not defined at negative 8. The lowest x value I can put into this function and get an output would be negative 4. And then this function is defined for all these x values all the way up to 4. But then after that, I can't tell you what f of 5 or f of 6 or f of 7 is. So our domain is that x has to be between negative 4 and 4. Our range is a similar idea, but it's all the y values in the graph. So what's the lowest y value? It's right here at negative 5. The highest y value is up here at 7. And notice this function is continuous. It goes all the way up to 7. So y can be any number in between negative 5 and 7. That's what we're saying here. If you really want to, you could put a y, but I'm encouraging everyone to start using function notation more, so that's why it says f of x. Number 21, this is a domain question. There are two domain issues that you should be aware of. The first thing is that in the real number system, we cannot square root a negative number. So anytime you see a square root symbol, I don't care about this minus 4 at all. It's not in the square root. But the thing in the square root, the radicand, 5t minus 6, cannot be negative. And the math symbol version of that statement is saying that it could be greater than 0 because that would mean it's positive, and that's not negative. Or it could be equal to 0 because that would mean it's 0, and 0 is also not negative. So if we solve this for t, we're done. Add 6 to both sides, and we'll get that 5t must be greater than or equal to 6. And then if I divide both sides by 5, I'll get t is greater than or equal to 6/5. You could also say t is greater than or equal to 1.2 if you prefer decimals. Number 22, this is the other domain issue you should be aware of. We cannot divide by 0. I don't care what this numerator is. It could be 2 or 3 or 4. The work would be the same. I cannot divide by 0, so that denominator, I just write an equal sign with a line through it to communicate that t cannot equal 0. And I feel like this was a little bit too simple. So I want you to try some extra practice. I gave you a function f and a function g. Remember, we can't divide by 0, so those denominators cannot equal 0. Try that on your own, come back and check your work. Here we go. So the denominator is x minus 5. Just write the whole denominator and say it does not equal 0, and then solve for the variable. I could add 5 to both sides and get that x cannot equal 5. Or for g, I could set the denominator equal to 0, or not equal to 0, I guess. Subtract 1 from both sides, I'll get 3x cannot be negative 1. If I divide both sides of this by 3, I'll be left with x cannot equal negative 1/3. 23 is asking for relative minimum points. So that's all the lowest points in their immediate area. So this point here is a lowest point because it's lower than all the points immediately to its left and immediately to its right. Same thing here. It's lower than these points and lower than these points. So number 23 are relative minimums are negative 5, negative 3, and 7, negative 1. Number 24 is asking for relative maximum points, and there's really just one. It's at negative 1, 7. I suppose, depending on how you interpret the ends, these could be relative maximums if these are endpoints. It's just not clear if there's meant to be an arrow or not. But if you said these are maximum points as well, I'd be okay with that. On the test, there'll only be one right multiple choice answer, but I didn't give you any multiple choice here. Number 25, identify the absolute minimum point. That's the single lowest point. So even though this is a relative minimum at negative 5, 3, it is not the absolute minimum. There's only one absolute minimum, and that would be at 5, negative 5. Number 26, again, there can only be one absolute maximum. In this graph, it's at negative 2, 6. Number 27, average rate of change is just the slope. So we need to find the slope, that's this slope formula here, using the point when x is 0, 0, 0, and the point when x is 2, that's 2, 8. So I plug these in, I have my x1, my y1, my x2, my y2, and I plug those in here, and I should get 8 over 2, which is 4. Number 28 is still referring to this table here. Over which interval does f have an average rate of change of 0? Remember, average rate of change is this slope formula, and if it equals 0, that means the numerator has to be 0. But y2 minus y1 would only equal 0 if y2 and y1 are the same number. So essentially what it's really asking is, can you find 2 points in the table with the same y value? On the final, it will be multiple choice and there'll just be one right answer. But since I didn't give you choices, there are 3 possible answers to this problem 28. You could say the interval negative 6 to 2 has an average rate of change of 0 because the y coordinates are both 8. You could say negative 4 to 1 has an average rate of change of 0 because those y coordinates are both 4. Or you could say negative 3 to 0 has an average rate of change of 0 because those both have y coordinates of 0. They have the same y coordinate. All right, on to this word problem about Ethan filling his glass tank with marbles. So he's going to put marbles in his tank and then top the rest of the tank off with water. And they give us the formula to represent W, how much water is going into the tank, and that's dependent on N, the number of marbles he puts into the tank first. So when it asks what's the glass tank's volume, the answer is 32 liters. And the way we could reason that is, well, what if we put 0 marbles in? If n is 0, I'll get 32 minus 0.08 times 0, and that's 32 minus 0, which is 32. So it's saying that Ethan would need 32 liters of water to fill the tank if there's no marbles in it, which means the tank has a volume of 32 liters. Now, if I tried W of 1, I didn't write it out here, but you can picture it. I would have 32 minus 0.08. I'd have like 31.92, right? But the volume, the amount of water Ethan would need would go down by 0.08 liters for every marble he uses. And so each marble has a volume of 0.08 liters. Moving on to 31, we have two different functions. Be careful with this one. This function is not the same as this function. Function g, we're not given the graph, we're just given the equation. And function h is the opposite. We're given the graph and not the equation. And then we're going to be asked questions about their y-intercept and their slope. So you should be able to tell me that g has a slope of 3 and a y-intercept of -5. And this graph h is still a function, and we can pick out its y-intercept. It's at -2, and it has a slope, a rise over run, of 2/4, which reduces to 1/2. The first question we're asked is, which function has a greater value at x equals 0? In other words, which one has a greater y-intercept? Well, what's greater, -5 or -2? -2 is the greater number, so h has a greater value at x equals 0 because -2 is greater than -5. The second question is, which linear function increases faster? In other words, which one has a bigger slope? Well, what's bigger, 3 or 1/2? 3 is bigger, right? So g of x increases faster because its slope is 3, and that's greater than the slope of h, 1/2. Number 32, Jeremiah is mowing lawns for a summer job. Actually, let me pause for a moment. This pink part here, please write that. There is a small typo that greatly affects the outcome of this problem. It should say his hourly fee for a 7-hour job is $84, and I'll explain why that is important. For every mowing job, he charges an initial fee of $6. So that's not $6 to mow the lawn. That's just, he's charging $6 to show up. And then he's also charging a constant fee for each hour of work. His hourly fee for a 7-hour job is $84. If we don't say hourly fee, then this $84 is including the $6 that he just charges to show up. And that's not what this is trying to say. In this case, we need to find out, okay, well, if he charges $84 for 7 hours, divide that to find out that he's charging $12 an hour as his hourly fee, his constant fee for each hour of work. And then we need to write the function's formula. F of t is going to be our slope, our hourly fee, $12, plus our starting point, our initial fee of $6. And this function would model his total fee. Here's the next one. Carson owes the bank money. To repay his debt, he paid $200 back to the bank for each month. Back to the bank each month interest free. Sorry. This is a really nice bank. It's not charging any interest. I don't think that's real life, but after 9 months, he still owes $18,000. And we need to find out what was the original amount of his debt. Okay, well, he paid $200 a month for 9 months. That means he paid back $1,800 or $1,800, and he still owes $18,000. So if you add those up, that means he started out owing $19,800. If you take that initial debt, that starting amount that he owed, divided by the $200 he pays each month, we'll be left with 99 months. It takes Carson 99 months to pay off his entire debt. Number 35. The graph below shows values for a function g of x, which is in the form g of x equals a times r to the x. Right off the bat, you should recognize that this is an exponential function. I have a point here, 0, 1. So if I plug in 0 for x and 1 for g of x, I'll get something like this. I can assume that the growth rate, r, is not 0. So any non-zero number to the 0 power is going to be 1, which means my value for a is 1. Now that should make sense because a, if you remember what that represents, it's our y-intercept. So you could have also, rather than solve for a using an equation, you could have seen, hey, the y-intercept is 1, so a is 1. We still have to find out what r is, though. So I can use this point here. I can plug in 1 for x and 2 for y, or for g of 1. And I would end up with this. I already know a is 1, and I'm plugging this 1 in and this 2 in because of this point on the graph. And 1 times r to the first power is just r to the first power, which is just r. And 2 is 2 the whole time. This means r is 2. We found our value for a. We found our value for r. Plug those in, and this should be our exponential function for this graph. Number 36 is going the other way. It says which graph represents this function. I didn't give you multiple choice. On the test it will be, but here's a sketch of what the graph should look like. Use your starting point, your y-intercept, and your, in this case, a decay factor. So it's going down from left to right, which means this point would be the point -1, 4. Number 37, you should be able to switch from fraction exponent form to radical form. Keep in mind the numerator of the fraction stays in the exponent, and the denominator of the fraction is the index, or the number in the crack. We're going to do the same thing for 38. K to the 1 over 38 power is the 38th root of k. You could say k to the first if you really want, but k to the first is just k. Number 39, we have negative 216 to some power. Now this means a -1 times 216 to the power of -1/3. Remember that multiplying comes after exponentiation. So this -1 here, if there were parentheses around it, it would be a different story. But there's no parentheses around this -1. So we are going to exponentiate the 216 and then multiply our answer by -1. Right off the bat, I see a negative exponent, so I can make this exponent positive using my negative exponent rule as long as I flip the base or use the reciprocal of the base. So the reciprocal of 216 is 1 over 216, and this negative just stays outside. It stays outside again, and then I can use my radical form. So I can turn 1 to the 1/3 power as the cubed root of 1. And 216 to the 1/3 power is the cubed root of 216. And remember, this negative sign is still staying outside. So there's that negative sign again. We lucked out. The cubed root of 1 is an integer. It's 1. And the cubed root of 216 is also an integer. It's 6, because 6 times the third 6 is 216. And that's our final answer, -1/6. We have a similar problem here. The 1/4, or 625 to the 1/4 power is the 4th root of 625, or what number times itself 4 times gives you 625? That's 5. 41 and 42 have that same negative in front of an exponent thing, and since there's no parentheses that are including the negative in the base, That means the minus sign needs to stay outside because we exponentiate before we multiply by -1. Flip the base because the exponent's negative, so instead of 125, I use its reciprocal, 1 over 125. And now this exponent is positive, which means I can cube root the numerator and denominator. The cube root of 1 is just 1. The cube root of 125 is 5. And now we can multiply by that negative to get -1/5 as our final answer. We're going to do something similar here. Leave that minus sign outside for now. And 27 to the 2/3 power is the cubed root of 27 squared. The cubed root of 27 is 3. I still need to square it before I multiply by that -1. So 3 squared is 9. And 9 times -1 gives us our final answer of -9. Go ahead and check your answers for 43 through 51. We are using our exponent rules, so these two have the same base, so I can add the exponents, 2 to the 9th, or 512 if you multiply it out. Same thing here, same base of 5, so I can add the exponents. -5 plus 6 is just 1, so my final answer is 5 to the 1st power, or 5. 45, I have a variable, so I can't do anything except add the exponents. G squared is our final answer. 46, we subtract exponents, so depending on how the problem's worded, we might be able to say it's 2 to the -4th power, but sometimes the problems say make sure all your exponents are positive, so we could use that negative exponent rule to flip the base and make the exponent positive, and we'd have 1/2 to the +4 power. Now, 1 to the 4th power is just 1. 1 to the 9th power is just 9. I'm sorry, 1 to the 9th power is also just 1. So 1 divided by 1 is just 1. You could have also used your subtraction rule. You could say 4 minus 9 and say that's 1 to the -5th power. But again, that's just going to be 1. I'm going to leave the rest up to you. If you have questions on these, ask me in class. I don't think you will, though. 52 and 53, check your answers for these. And I'm going to stop there. This will be a 2-part final study guide walkthrough. In the next video, we will pick up on number 54 and go through the end of the study guide.